Okay, so the question that we have says a railroad track crosses a highway at an angle of 60 degrees. A train is approaching the intersection at the rate of 40 kilometers per hour, and a car is approaching the intersection from the same side as a train at the rate of 50 kilometers per hour. If at a certain moment the train and the car are both 2 kilometers away from the intersection, how fast is the distance between them changing? So let's say um, let's say we have our rail track like this. Um, okay, so let's say we have our rail track like that. All right, let's say we have it like that. Of course, we can make it like that. Doesn't really matter as long as we just follow what the question is saying in terms of the information that we have been given. Then we have also been told that this is the road track here, and it crosses the highway at an angle of 60 degrees. So now let's assume to say we have uh, we have the highway, okay, like that. Okay, so if we say this is our highway, okay, this is our highway, then this is our rail. Okay, then we have a train. Okay, I'll just do that. uh, we have a train approaching the intersection. So in this case, the intersection that we are talking about is the intersection at this point. Okay, that's where we have the intersection there. Okay, this point is our intersection. So the angle in between the rail and the highway, we have been given as what? As 60 degrees. Okay, so the angle there we can say is what? Is 60 degrees. So if we say this is our train here, we just have something like a figure to give us a guide. We say that's our train. Uh, okay, say that's our train there. Then we also have a vehicle approaching this same intersection, going in the same direction. Okay, all right. So we have something like that. So one other information that we have been given is that we are told that the at some moment, um, at a certain moment, both the train and the car, they are 2 kilometers away from the intersection. So we are going to say, let's say this point here. Let's say this point, from this point going to that point there, the intersection. We say it's what? We say it's 2 kilometers. Okay, so it's 2 kilometers. Then for the train, I mean for the car from this point and to that point there, we say it's also what? Um, we say it's also 2 kilometers. So the question is that how fast is the distance between them changing? So the distance between the train and the car that we're talking about is the distance that is at this point. So if you see that it's going to be changing bit by bit, is getting smaller and smaller and smaller and smaller until you reach the what? Until you reach the intersection. But we are told that uh, the train is moving at the speed of um, 40 kilometers per hour. Okay, then the car is moving at the speed of 50 kilometers per hour. Okay, so we have to determine how the distance between the train and the car is changing, and that's the distance that we are talking about there. So without even wasting much time, what we are able to understand here, or what we are able to observe, is the fact that we are dealing with the cosine rule. Okay, so for us to be able to find this distance here, we are simply dealing with a cosine rule, because we have the two sides and we have an angle. and you have to find the side that is relating that angle. And if we are to name this side, okay, if we are to name this side as let's just say this is C, okay, then we say this is A and this is B. um, according to cosine rule, our C squared is going to be equals to our A squared plus our B squared minus 2AB cos C. Okay, cos C is the angle, which is this one there. Okay, then the C is the side that we are looking for. Okay, so remember to say these are rates of change, and what we want to find is the relationship between everything that we have here, the A, because the value of A is going to be changing as well, the value of B is going to be changing, and at the end we're also going to have the value of C changing. All right, so before I differentiate both sides of the equation that I have, I'd want to I'd first of all want to try to get rid of perhaps getting rid of the sign that I have here, which is the cos C. Okay, so here I'm having my C squared is equals to A squared plus B squared minus 2AB. Then I have cos what? Cos 60. Cos 60 is half. So half is, we're talking about 1 over 2, so the 2 is going to go and that 2 is going to go there. So meaning, instead of me writing the cos there, I'm just going to write minus ab like that. Okay, so now we can differentiate both sides of that equation. So you can say we are looking for if you differentiate both sides of this equation, it's more like you're talking about implicit differentiation. So this is, you're going to have 2c dc dt is changing with respect to time. Then you're going to have 2a dA dt, okay, plus 2b dB dt minus, we have product rule here, so we're going to have a dB dt minus b dA dt. That's the equation that we are dealing with. Alright, so remember to say here what you are looking for is dc dt, the rate of change of c with respect to what? With respect to time. Okay, so here we first of all have to find what c is. Okay, we first of all have to find what c is in this case. So to find what c is, we are going to of course use the cosine rule itself. We have a, we have b, we have the angle, so we are going to say our c is going to be equals to the square root of our a squared. Our a squared is what? Is 2. I mean our a is 2, so meaning a squared is 4. Then our b squared is also 4. We have what? We have 8 here minus. So here we're going to have also 8 cos what? Cos 60, which is half. So meaning you're saying c is equals to 8 minus 4, because here we're going to have cos 60 is half, so it's 1 over 2. So 2 into 8 is 4. So we're talking about c being a root of what? Root of 4, and you have what? You have 2. So meaning even c here is also equals to what? Is also equals to 2. Okay, so now we have everything that we need to replace in that equation. So we're going to say 2 multiplied by c is what? It's 4. Okay, dc dt is equals to 2a, 2 multiplied by a. Okay, 2 multiplied by a, what we have is our a we have been given, to our a have been given as 2, meaning this is going to be what? It's going to be 4. Then dA dt is a rate of change of a with respect to t. In this case, we are talking about the distance of the train. I've indicated a for the train, b for the car. So in this case, we are dealing with 40 kilometers per hour plus 2b. Our b is also 2, meaning we have a what? We are going to have a 4 there, multiplied by dB dt, which is for the vehicle, or let me say the car in this case. So we're going to say 50 here minus our a, which is 2, multiplied by dB dt is 50 minus 2 multiplied by the 40 there. Okay, so we're going to have a 4 multiplied by dc dt is equals to when you say 40 by 4 is 160 plus plus 4 by 50, you're going to get 360. 360 there minus, so that would be minus 180. Okay, so 360 minus 180, which is simply 100 and what, 180. So we have 100 and what, 180 here. Okay, so now we are going to say our dt, making it decide with the formula, it will be what, 180 divided by what, divide by 4. Right, so what you're going to have is that the rate of change uh, of c with respect to time is going to be equals to what, it's going to be equals to 45. Okay, it's going to be equals to 45, in this case we're using kilometers per um, it's going to be kilometers per hour. We have been given hour there, so that's how we are going to the distance between them is going to be changing at the rate of 45 kilometers per what, per hour. So that's how you go about answering that question. Thank you very much for watching.